So again, we are doing the same thing we did before with factoring. The only difference is we are solving with this. So just to start off, I'm going to do a couple factoring problems. Again, this should be a review. I'm hoping this is at least, I'm hoping it's easy, obviously, but hopefully it's at least familiar. The trinomial factoring, I would X. The top number is your first times your last number. So mine is -24. -24, to add it to be -5. Now again, if you can come up with those two numbers right off the top of your head and you want to put them in there, you can. If you can't, I would go ahead and list all the factors. So -1 and 24, -2 and 12, -3 and 8, -4 and 6. I apologize if that was the actual bell. I don't know why they do a minute bell for lunch. It's super confusing. There's 55 bells. Anyways, all right. So which one of these add up to be -5? Again, we have the 3 and the 8, but that adds up to be +5. So you've got to switch both of your signs. Now, again, this is a really good time to break, check your work. I would just put my calculator and check negatives and positives. 3 times -8 is -24. 3 plus -8 is -5. So once you have those, x plus 3 and 8, if there's, that's when you need to divide. If there's not a number in front, you can leave it like that. So moving on to the next one, do have a number in front. This actually ends up being fairly similar to the last one. I don't remember if I did it on purpose or by accident, but that's okay. So 2 times -12 is -24. Factors of -24 that add up to be -5. Again, we just did this. It's 3 and -8. If you need a list amount, you can, but we just did that. Again, I don't know if that was an accident or if I did that to say, but I can't change it. So you end up with the same thing, x plus 3 and x minus 8. But remember, you're not done yet. And again, a good way to double check, if you ever want to go ahead and multiply this all out, first 2 and multiply the first number. So x times x is x squared, not 2x squared. So that doesn't work. So we still need to work on this. You have to divide by that 2. So divide by 2. We can't reduce the 3 over 2. The 8 over 2 reduces down to 4. And then remember, you cannot have any fractions in this. So if you do have any fractions, you move that denominator to the front. So it's 2x plus 3 and x minus 4. And the last one, we have x minus 36. Hopefully you guys recognize this as a difference in squares. Guys, could you hold on that, please? Thank you. X squared is x squared, x times x. So your a is x. Your b is 6 because 6 squared is 36. So you end up with x plus 6 and x minus 6. Now the only one that we do that you'll see is we can take out a greatest factor. I'll do one of those today. But other than that, we're not going to have any factor by grouping problems that we have to solve. And we're not going to have any sums and differences of cubes that you have to solve. So it's either going to be difference of squares, factor, or it's going to be the trinomial factoring where you use the x. Those are the only 3 options that we're going to do factoring in this chapter. So again, hopefully that is familiar. Hopefully it's familiar, and hopefully if it's not, hopefully that kind of helped your memory a little bit. Product property. So I'm trying to work with little baby steps here. And the way we're actually solving these is the zero product property. And that property is something that even if you guys don't remember or haven't ever heard of, you use it a lot. It's one of your favorites. So if you have 0 times x is equal to that x could quite 0 is 0. Times a binomial. It doesn't matter what we get for that binomial. You can plug in 10, you can plug in 20, you can plug in 100, you can plug in negative 100. It doesn't matter because 0 times anything is 0. That's the concept of what we're doing today. We know that they're equal to 0. All we need to do is one of the multiplications or one of the things we're multiplying to 0. So the new part for today is this next one. We're supposed to solve the following. Essentially, I skipped the part on these two where you have to factor. I already factored for you. I set them up this way equal to 0. So now I have to just solve them. So this is the only new part for today. Again, in my opinion, it's not necessarily the hardest part of today. Just like we said, this one to equal 0, just like before, anything times 0 is 0. So if I can get this set of parentheses to equal 0, I'll give it 0. And if I can get this set of parentheses, that'll be 0. That'll give us what we want. So if we can get either one of those to equal 0, that's going to give us our answer. So the long way to so x plus 6, what makes that equal to 0? That's what we just said. We want that to equal 0. So subtract 6. X is equal to negative 6. And x minus 10 equals 0. Oh, sorry. I want that as well. So I add 10 to both sides. X is equal to positive 10. Those are your answers. And again, if you plug them back in, it makes sense. I don't expect you guys to do this on every problem, although you could if it would work. But if you go really quick, negative 6, you plug that in here, negative 6 minus 10 is negative 16. But negative 6 plus 6 is 0. So 0 times negative 16 is still 0. So that's what we want. We want it to equal 0. If you plug that one into, we get 16 0 is obviously equal to 0. So again, what are we going to plug our answer? Now, this is the longer way to do it. I know some of you guys see the shortcut here, or you notice something that could be a shortcut, where if I have a positive 6, my answer was negative 6, and if I had a negative 10, my answer was a positive 10. Now, I'm going to try to refrain from that, and that's what I mean right here. A lot of students do that, and for the most part, you're fine. But as soon as you get to a problem like this, where there's 2x plus 3, a lot of people say negative 3, and that's not right at all. Instead of saying it's the opposite of what this is, I always say, what makes this 0? So x plus 6, what makes that 0? Well, again, hopefully, if you think of it that way, it's still pretty obvious it's negative 6. Negative 6 plus 6 is 0. What would you plug for this x to get 0? Well, hopefully, it's pretty obvious it's positive 10. 10 minus 10 is 0. So work if you don't need to. But again, I think students think of what makes it 0 rather than it's just the opposite of what you see. Like I said, the next people miss the 3 and positive 2. So if you can't tell, what would you plug in for that to get 0? Some of you guys know already it's negative 3 over 2, and that's great. If you can do that in your head, by all means, you can, or that's great. But if you're like me, I'm not good at that. And so if I ever had a number in front, I usually do this. But if I can't tell what makes it 0, I then do set it equal to 0. So I 3, 2x is equal to negative 3. So both sides by 2, I get x is equal to negative 2. So that's one answer. The other answer, again, if you can tell what it is off the top of your head, you can do that. I'd prefer if you show some work, but we can talk about that a little bit later. And then when you solve this, add 2 to both sides, divide both sides by 5, I get 2 over 5. Common, and in fact, that's why it's always going to be, if you have a number in front, in your parentheses, that means you're going to get a fraction for your answer. I would like to say every time, but I guess I don't know, so I'm going to say not. If you have a number in front, then you're going to have a fraction for your answer. Now, last but not least, when we move on here, or before we move on, when you list out your answers, I'm not super finicky on how you write your answer as far as notation. If you want to do it this way, you can. we just have two separate x's. If you want to list it out where you put x is equal to negative 3 over 2 and 2 over 5, or negative 3 over 2 comma 2 over 5. I don't care which way you do it. The only thing that I would recommend is make sure if you're going to use a not use parentheses. Because if you use parentheses, all of a sudden that's an ordered pair, and that is not the right answer for this. So again, I'm pretty lenient to put your answer, but if you put it as an order, that counts you wrong because that's not what we're finding at all. Okay. So now we're going to get into the nitty gritty of this. So again, actually, I should take a second. Are there any questions over number 3 and number 4? That's the new stuff today. Other than that, it's factoring. We factor to get to that point. And again, I'm not saying that it's easy. I'm just saying that we've done it already. Okay. You want like 2 more minutes left? Must be looking on schedule. We're good. So on this solving, you have to get it equal. Only one method where you don't put it equal to 0. That is completing the square. I don't think we're going to do completing the square this year because it's. So we make this equal to 0 first. So I have to subtract 2x from both sides. Make sure you are like terms. That 2x is not an x squared. It's a constant, so it's not that x. So you end up with x squared minus 5x plus 2 is equal to 0. You got to get 0 on one of the sides. To 0, we end up with that on the right hand side. But the rule of thumb is make sure you have a positive x squared, whatever that's going to be. But again, I don't think that's. For this one, so factor, we are looking for 3 times 2 is 6. Factors of 6 to add to be negative 5. Again, if you don't know what that is, you can list out your factors. 1 and 6, 2 and 3. Again, it's positive 6. So 1 has to be 5. Has to be negative 5. But remember, that adds up to positive 5. So I need to change them both to minuses. Negative 3, negative 2. This is a great place to double check. Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. And this is one of those tricky ones that 1 and 6, if you would have just changed one of those signs from a positive to a negative, it would have been 1 and 6. So this is a really good one to make sure you're double checking that stuff. So x minus 2 and x minus 3. Now, you don't actually, if you don't put this, it's going to count you wrong, but just consistent, that is equal to 0. That's the idea. Now, that's not quite your answer yet. Remember, we have a leading coefficient of 3. So now we have to divide both of these by 3. The fraction is 3, and 3 divided by 3 is 1. So I keep second guessing that it's negative 2 and negative 3, but that's all right. I think we're good. Then move your flux. We have 3x minus 2 and x minus 1. This is going to be positive 1. The other one, if you can't tell, what makes this set it up? I add 2 to both sides. I get 2. Divide both sides by 3. I get x is equal to 2 over 3. So those are your 2 answers. Now, I will give you a bit of a shortcut, and I'm only going to say this once because I'd rather you get practice with factoring because, again, we will get to a chapter where we have to factor like 4 times in one problem. So you guys need to stay sharp with factoring. So I'd rather you not take the shortcut. But just to take it took me a while to realize this, mainly because This is like last year, my first year, used this factoring method extensively. But when you're solving, rather than taking the denominator up front, if you just left it as x minus 2 over 3, you're subtracting 2 over 3, be positive 2 over 3, which is what our answer is. That's not a fluke. So there's that little shortcut. Again, I'm not going to talk about it after that. I'm always going to factor it completely because I like to get you guys some practice with that. But I thought about not telling you guys and figuring that those of you who actually do a bunch of these problems will probably figure that out. But I told first period, so I guess I'll stay consistent. So the next one, number 6. For this one, same thing. You need to get 0 on one side, so I subtract 11. Again, you have to combine your like terms. So for this one, hopefully you notice there is no x term. There's no middle term. Now again, if you didn't notice that and you went ahead and did the x, it would be factors of whatever 4 times 81 is. That would add up to be 0. If you want to do it that way, you can. It's possible. But hopefully you notice, since it's a binomial, double check difference in squares. If it's a binomial, for this chapter, it's either difference in squares or you can take out a greatest common factor. So for this one, my a is 2x, my b is 9. Again, your a squared is 4x squared. 2x times 2x. 9 times 9. So you end up with 2x plus 9 and 2x minus 9. Again, that is equal to 0. And now we solve this just like we were doing. So again, we have 2 parentheses. If you subtract 9 from both sides, you get negative 9. Divide both sides by 2, I get negative 9 over 2. Now, if you want to do all the math again, you can. But since this is a positive 9 and a negative 9, it's just going to be the other answer. You're going to have a positive and a negative. If you want to be super fancy, you could do plus and minus 9 over 2. You don't have to. I would probably just do it this way. But again, you can save yourself a little bit of work if you notice some of that. Again, I know I've said this before a couple times, but just to remind you, in this chapter, you're going to have the x factor with the trinomials, difference in squares, and greatest common factor. Those are the only 3 methods you're using to factor. So last but not least, I know this says this is a you-do. I'm going to steal it from you because I should do one like this anyways. But this one we have 2x squared plus 6x is equal to 0. Now again, it's a binomial, so the first thing I would like you to think of is difference of squares. Well, that because it's not difference, it's factor. And then 2 is not a perfect square, and 6 is not a perfect square. So there's not a difference in squares. So the only other option is taking out a greatest common factor. In this, yes, you can. You can take out a 2x. So x plus 3, 2 is 3. I had 1x, I took it out, so it's not 3. If you want to get to the point, they get one of the answers. Say x is equal to negative 3. But for whatever reason, a lot of people get the other one, or they either get the other one wrong or forget about it. But again, this is where I want you to use the same thing I told you before. Don't just look at this sign, because a lot of people have negative 2. Not negative 2. What would you sub in to make this 0? Well, 2 times x would be 2 times 0. So that x for that one is 0. Again, I would like to every time, but I am hesitant. I think it's every time, but I'm not 100% sure. So I will say definitely the vast majority, 99% of the time, if you that means you're going to have 0 for one of your answers. And again, it doesn't matter if you take out a 2x, if you take out a 15x to the 5th, it doesn't make any difference. If you plug 0 in for that x, 0 to the 5th is 0, 0 then times 15 is 0. So even if there's crazy exponents and crazy numbers, whatever you pull out, what would make that 0? It's got to be 0. So have you guys and start your worksheet over this. There is an exit ticket or a homework check, so make sure you're not forgetting to do that. If you have any questions, let me know. And again, this whole chapter is over solving. So we did this one. Next thing we'll do is quadratic equation. So we'll do the quadratic formula for a lot of these. So make sure you're keeping up with this stuff.